now let's start the first session of the day, Expert Talk, AI for Energy Storage and Smart Grid. I welcome Rajendra Nath Goswami from Bosch with Narasimhan Santhanam, Energy Alternatives India.
Nath Goswami, I represent Bosch, and it's my privilege to be here with you today and share with you what we are doing in the energy transition space and, of course, how is AI impacting it. Yeah, so for us in Bosch, we are focusing primarily in the energy side on the distribution and the consumption side of business, not necessarily the other two for the value chain. And today, the transmission and the consumption side is probably shrinking faster. And one of the key elements there is the storage, which brings together a lot of technologies together, right from electrochemistry at the cell level to digital twins to even AI. Yeah. So for the session today, I have chosen to share with you a little bit about what we are doing in the energy storage space and how we have applied tech and deep tech in this space. So let me just start by just talking about the battery energy storage systems, which is becoming more and more frequent in the US and in other countries, of course. I think it's helping a lot in the grid management. If you look in India over the last couple of years, DISCOMs have been releasing RFPs in the battery storage space because they want to bring more stability to the grid. And as the demand for energy increases, and there are different forms in which energy will be consumed, I think we need stabilizers, we need such storages to, first of all, manage the grid, and also going forward, it will also help us, make the balance of energy transition much more smoother. And how is that? So first and foremost, you get more grid stability. So the three motivations I've listed out here for adopting more and more storages. Yeah. So in terms of grid stability and reliability of the grid, energy cost optimization. So there's a huge benefit when you have a storage possibility in terms of when you charge, when you discharge, at what cost you charge. And last but not the least, of course, you can also integrate that to renewable sources, right? And hence it contributes to your renewable objectives. Having mentioned that, I think it's also important that to mention that the global storage market is actually fast growing over the last few years. Those who follow that would know the CAGR is in mid double digits. Of course, it will cool down over time, but there's still a lot of space. Over the decades, I think we will see more and more technology interventions happening in this space. Yeah. And hence, we see a lot of opportunity growing in this space. And last but not the least, of course, I think it's important that when you talk about these kind of complex systems, I think their lifetime usage, the investment of the capex, and the return on the invest part, and the life of the asset becomes very, very critical because it's significant investments. If you follow the contracts that are getting signed today, while the power purchase agreement and the per unit cost is shrinking, the cost of the asset is not. Yeah? And more we would have to become more self-reliable because of where we source the cells, the battery chemistry, and how do we manage that. Yeah? And at the end, of course, disposal. So I think there are a lot of areas where work is still ongoing, and it's a very interesting topic. That's why I chose this for today. Yeah. So just to get everybody in the audience a little bit of understanding about how this battery energy storage system works. Yeah, I just got the architecture along. I'll not go into too much of detail and bore you on that, but for you to understand, I think you can just imagine that there's a source of energy which the battery storage uses to charge, and of course there are sinks, so where the consumptions are there. The consumptions are there across the board, right? There are different types of consumers. Yeah, some are prosumers who produce and consume and upload into the grid, and there are only consumers also. Some are very high energy consumers. So this creates some instability in the grid, and that's where this plays kind of a accumulator role. On the other side, there's also a lot of different subsystems in terms of different sources being in DC current or AC current and how you manage that. So if you have got a grasp of the architecture, I think what I would like to talk about is how storage energy is being impacted on AI. I was just outside, reading some of the startups working on this field. I think there are a lot of some interesting startups I read about, and I was told by Narsi that I think there is a lot of interesting talks going on in the AI space. So maybe my interest is to share with you some real-life applications of AI today, already in this space. There's a lot of work going on, but it's also a question of where we are investing on AI and what are you getting out of that. The return of invest is very important to run a sustainable organization, right? And first and foremost, the critical elements are, of course, the cells. How do you manage the cells? And there's something called a battery management system, which helps you manage the cells at an individual pack level, at a container level, right? And there's a lot of tech which goes into that, managing that. I'll come to the details. Second one I would talk about is, when you have some amount of energy available, it's not just having it, right? You got to apply the laws of finance onto that, yeah? Primarily, what works on a battery energy storage is the laws of physics or electrochemistry a little bit, and on the other side is the laws of finance. So energy arbitrage and marketplace participation, as well as forecasting and prediction, are two topics which help you exploit an asset like a battery energy storage. Yeah, you make an investment, you surely make an investment to get a return on invest, right? And this is where we have AI interventions, in fact, agentic AIs, which manage the complete workflow. Today, a lot of this is manually done, and it's handled pretty well. But we feel that going forward, as the scale of operations improves, there's a lot of potential for applications here. And last but not the least, when you invest in a capex on such an asset, you are obviously interested in the asset health and the remaining useful life. Yeah, so I'll just leave an overview about each, because each of them goes into a lot of reasoning models, a lot of machine learning models built into it. First and foremost, if you look at cell balancing, right? It's not just not your mobile phone cell pack we are talking about. These are massive 20-feet container, 40-feet containers where, stacks of battery packs are put together, right? And of course, when you do that, you can imagine when there are thousands of cells, yeah, there is a differential behavior among all of these cells, and you need to manage that, right? And this is not something which is even manually feasible. So that's where technology comes into play in understanding the performance of the cell, and the performance of the cell is on day 1 is not the same on day 365, right? Depending on how it has been used, charge and discharge cycles, thermal events, all of it, it tends to differ, and that's where the cell balancing comes in, and this is where we use RL models here to help manage this more efficiently. There are passive cell balancing strategies and active cell balancing strategies. So depending on what you adopt, you get some different approaches, and the benefits are, of course, accordingly realized. Second one, of course, is on the energy arbitrage and market participation. Yeah, I was mentioning here, of course, this is a little bit on the finance side of managing, but even here, a lot of models are applied to ensure there's no loss in opportunity, right? There's no loss in terms of cost leakages, right? In terms of charging, choosing which is the source to charge, why at certain point of time you choose a certain source, right? And then, of course, when it comes to consumption, how you deploy the consumption, how do you manage the consumption, when do you dispatch out, when do you consume internally, right? So while this is also manually done, I think more and more of logic. Initially, they started off with rule-based systems, but going forward, I think more and more intelligence will come in, where it's not just a few rules which define, but it will be dynamically decided how and what decisions will be taken, right? Subset of that is also prediction and forecasting, because when you use renewable energies, you are dependent on nature, yeah. And of course, there are cyclic changes over a period of time. So I think to bring in these factors, you can bring in an additional dimension of how you apply AI models and AI decision processes, yeah. So this is about forecasting possible power generation, and accordingly when you put out contracts, when you execute contracts, and you want to choose for spot contracts. Long-term contracts are of course decided quite early, but when you participate in spot contracts on the energy exchange, then these kind of models and decision processes will help you become more efficient in your choice. And that's how the end objective is to you maximize the investment returns. Yeah, so most of it that I spoke about would address things on the short term. Yeah, these are at the moment in situ applications that I spoke about earlier. The last one I want to cover talks about long-term view. How do you balance short-term decision making with long-term priorities, right? So your asset health has a huge impact on your decision process. Your whole charging and discharging cycles, yeah, need to be regulated, and there are trade-offs that have to be decided between whether you should take the benefit of a lower charge cost right now, or should you regulate the charging process through a slow charging process because your asset health has to be managed in a better way, right? So I think this is exactly where the more and more variables, the more and more parameters based on which decision models have to be executed. I think that's where we see more and more adoption of intelligent systems. Yeah, and of course this is a ripe area for where AI comes to use. Remaining useful life is not a new topic, because whenever we did a term sheet, for example, in terms of investments and replacement investments, we always did a remaining useful life using fundamental mathematics in the past, and these mathematical models are now getting implemented into automated systems, and they will help you more effectively decide. So when you talk about asset health, right, there's also another critical element which impacts asset health, and that is thermal incidents. So when you adopt automated models, I think it's also important that you keep in mind the safety of the systems, and that's where your thermal incident management is also very important. Safety, security are today more like hygiene systems when you design such storage systems, yeah, but they also have a very important role to play when we design the models. So for me, I would say, the potential and the opportunities are many, but these are the 4 key areas where we have deployed AI, and the session is largely on AI, and your interest on AI. I hope this whets your appetite in understanding about where we have been able to implement AI and get returns in terms of practical implementations. There are many more areas to work on, yeah, but that's why the future on this topic is still very exciting. As I bring my presentation part to a close, I would also like to leave some food for thought for all of us, yeah, for sure, for me, for my team, of course, but of course I'm sure all of you take interest on the topic. So there are still a lot of challenges ahead for us, and that's what I like most. Yeah, so when you talk about battery, I think the chemistries are changing, new chemistries are going to come up, yeah, especially on stationary systems. I think we look forward to the challenges that these kind of new electrochemistries are going to bring up. Second, I was speaking of regulatory and safety. We notice that automated systems also need to understand the nuances of how we do trade-offs, yeah, especially on the safety side of it. Certain applications, while we are working more and more on electrochemistries that are more stable and more safe, even in varying temperature conditions, we still have to care for the models to take decision processes in a way where we do not trade off with safety. Cost benefit trade-offs, yeah, so while we can do a lot more with technology comes at a cost. So it's always the question, how much am I going to invest and what return do I get out of that, right? So we can get a lot of very high-end sensors, but each of them come with a cost. So there is always that balance which you have to achieve, and I am sure going forward we would see more and more models replacing sensor costs, physical sensor costs, because physical sensor cost is not a one-time cost, it's a lifetime cost, right? Because it has to be maintained, it has to be replaced over a period of time. And we are talking about topics which have a 15-year, 20-year life prediction. It's not just use and throw kind of material, yeah? On the other side, the complexity, and I'm sure more and more of, you know, math will come into this topic. So we'll look forward to that. Um, generalization and transferability, yeah, these models, you know, they are not all the same. So when the electrochemistry changes, you know, the power capacity changes, this brings also new challenges. So I think that's a lot more work to be done in terms of portability of models across different systems and subsystems. And last but not the least, I think the safety constraints and the verification part of it. Yeah, how do we ensure that when models are deployed? Because when you generally tend to believe that when this such kind of AI models are deployed, you know, things are taken care. Of course, there's a human in the loop part, but the cost optimization drivers, yeah, push more and more into automation. So there's a fine balance required between how much of AI we want to adopt to ensure things are working efficiently, but at the same time, also that it does not compromise the essentials of operations. Yeah, these are areas which are still work, and I welcome all of you to also, you know, be part of that. We from Bosch are focused on this division, and of course, we also look for partnerships. And with that note, I say, for me, partnerships are pivotal. A lot of our successes happened working together as a part of an ecosystem rather than an individual organization, and that's what I would look forward to. That's as for now from my side, yeah, as a summary, and maybe now I would like to sit down for the discussion.
Thanks, Rajendra. Firstly, thank you very much. I've been in touch with Rajendra for quite some time. I can. It's not working? Yes, sir. I've been in touch with him for some time. We had met at a few trade shows. Oh, it's been over the years. So it was a pleasure when he replied to me last week saying, look, I'll be happy to do this because it's not too many guys who are doing AI implementations at an engineering level or at the power grid level at scale. There's a lot of talk, and it's very difficult even for consultants like us to figure out what is wheat and what is chaff. It's very, very difficult. So I wasn't sure who I was going to put for this. And then when he sent a note saying he was willing to come down, I was very happy because guys like Bosch at their levels of sophistication and resources, they are capable of getting some things done on the ground right now. And I'm glad that he pinpointed a few things. So for you guys sitting in the audience, this is combination of AI, but also for, there are intersections with deep tech. If you're talking about battery storage, if you're talking about grid, sure, there's a large software component. I think you're also dealing with a lot of hardware systems in the entire ecosystem. If you're talking about batteries, battery management systems, well, most of the time you're dealing with the cells inside, with the electrolytes inside. So I think this is deep tech to me, in my opinion. So it's a great intersection of AI and deep tech. I'm going to ask only a few questions because this is a very deep topic, and I am also learning, by the way. I just told him what we know back at our company is we are doing a lot of work in the intersection of AI and climate tech. Most of them more at a research and consulting level, and we have put up something outside for those of you guys, about 20, 30 case studies we have put up based on what people are doing around the world. We also published a booklet, AI for Climate. Only about 100 copies are available. So if you guys are really working or keenly interested in that, you can collect it from the registration table. It's just a limited number of copies I put down for those of you who are interested. So that's been our work. But I know guys like Bosch bring to the table something far more hardcore. So my first question, Rajendra, is how did you come to work on AI intersection with all the things you spoke about? What has been your background in the last few years?
Yeah, so I've been working on the energy topic for quite a long time. Yeah, so initially, of course, Bosch has a focus on the EV side of mobility side of electric business. But then, if you look at the value stream, I think while EV is one part of that, and it's more on the demand side of it, and of course also on the sustainability and green tech, I think there's a lot more to be done. Yeah, so we have looked at the whole complete value stream, right from generation, transmission, distribution, and consumption. Yeah, broadly, if you look at that, and storage also now an integral part of that, we have strategically make a decision that our strengths lie more on the distribution and the consumption side of it. And I have been working in this space. So it's not that AI does not apply on the others. Of course, as much it does. Yeah, if you look at the energy exchange, right, the way it operates, I think more and more of this will come into place. Well, AI is not new to us, right? We have been doing rule-based systems. We have been applying a lot of mathematical models in the past. But now, I think access to cheaper compute, storage, and of course, a lot of talent have enabled me to bring these mathematical models into life and deploy them in real time on systems, either on the cloud or even on the edge, to get the desired results, right? There's a lot of security concerns associated with application of AI. You know, you can poison the models to kind of hinder the decision process. There could be model drifts which you need to care for. Explainability is another key aspect of adopting all of this. So I think these are things which have become very prevalent in modern tech, right? And as an organization, I think we are towards business, right? And we need to bring these changes into the ecosystem and for the general good. So, if you ask me that question, I don't know exactly at one point, which point it
doesn't
happened.
matter. I think you've answered it.
But it is.
Let me move on to something more important.
Take that forward, yeah.
You explained a lot of use cases,
Yes.
things that you guys are already working on. Which of these are applicable for India in the immediate to medium, let's say 1 to 3 years? Are all these already being done for India, or are these global practices? And if they are global practices, which of these use cases do you see being applied to India in the next 2 to 3 years?
What I presented is more a practitioner's view, and I can underline this, that they are equally applicable in every installation. Yeah, and it's for the right way of operating that asset. It's a massive, costly item to put a battery energy storage.
For instance, smart grid.
Yeah.
Now, in a country like India, it may not be as developed or as ready as it is, let's say, in Germany.
Yeah.
So even though you guys might have done something in Germany in a big way, it may not be practical in India for a few years. That's what I meant. Are there some things in the list which you think are going to be coming up right away, and some things will take some time for India?
The 4 I presented are as much applicable in India. Why? Because if you talk about remaining useful life and asset health, you talk to any investor, yeah, and who has a term sheet, will tell you how important this is. Okay. So if you talk about forecasting, right? If you put such a costly investment, you would like to see that you get the best out of that.
I'm aware about
the payback period,
I agree
right?
with you. That's already, there's a lot
it
of...
is equally applicable in India. Equally.
Forecasting, I completely agree. Since I've been glued to the renewable energy space, there's a huge amount of work that's already going on implemented. Last question to you. You spoke about you guys want to work with startups, and that's in fact why I really wanted you guys to come down here. I'm sure there are quite a few startups here, they'll be joining, more will be joining. Two questions. One, a large firm like Bosch, you have your own protocols, your own systems. How do you integrate what startups are doing? They're all messy guys, right? I mean, I am a startup mentality myself, and the way we dress, the way we do things, may be quite messy for somebody like Bosch. So how do you integrate startups' work with yours without a lot of overheads? And secondly, what kind of startups would you really want to work with in India?
Okay. So we don't want to be that giant mammoth, yeah, in the world, right? We might have become a little bit outsized, but we always believe that nimbleness and agility are very important for us. So it's not now, we have a DNA program, yeah, discover, nurture, accelerate. You can check out in the public domain. Bosch runs accelerator programs on the DNA banner. I have been working with startups, and I have been mentoring startups myself. And some of you in the audience, I just happened to meet some investors outside who said that they already know that their startups working with Bosch. So that's good. There is public data available that it works. Where do we work together? Yeah. So there is. We don't believe that we have to make everything ourselves. Yeah. But we do have a network where we have access to the market. But this is not the only reason why we want to work with startups. We also want to work with startups because there's a strategic fit between what we are doing and what you may already have, where we would not like to reinvest. It's not like you have to rediscover the wheel. What is more important is speed to market. Really, that's the way to business, and that's where we work with startups, because there are many startups. I have seen fantastic solutions. All that is required is to integrate this to the larger ecosystem, or maybe a complementary fit to what we have, and that's where we go reach out to the market. We can take that to our existing customers as well as reach out to new customers.
Thank you. So you're saying all startups welcome, doors open. What should they do? Should they write to some division? Is there some email you can leave them with? I mean, I'm just asking because they're a startup, they want to meet you.
My email is out there.
So out there, yeah. Take a snap of that.
Energy side, at least I can respond to that.
Fantastic.
Because if there's somebody else in manufacturing or something, I'm not responsible. But maybe we can connect you to the DNA
Sure.
program.
Hey, thank you. Thank you, Rajendra. Thanks for your time.
Thank you for this very exciting subject, which is very close to my heart as well. I may like to share with you that we have developed in Auroville, near Pondicherry, a smart mini-grid, where we have distributed solar energy generation and distributed storage. And the philosophy is generate close to where you consume and store close where you generate. So, you know, in the past, there were always these big discussions about centralization and decentralization. And we have thrown both of these words outside of the window. And instead of having a debate about centralization versus decentralization, we say distributed generation and distributed storage. So this was a subject very close to my heart, and I think all of us got charged when you speak about battery charging. Thank you so much.